Hello, and welcome to our lesson on square and cube roots. In this lesson, we'll leverage our existing knowledge of powers to introduce and understand square and cube roots. We'll start by quickly recapping square and cube numbers. Next, we will explore the concept of square roots and understand how to determine the square root of a number. Then, we will explore the concept of cube roots and understand how to determine the cube root of a number. Finally, we'll apply this new knowledge to an example to solidify our understanding. In our previous lesson, we looked at squaring a number. When we raise a number to the power of 2, we call this process squaring the number. If we have a number, n, its square is written as n squared, and computed as n squared is equal to n times nth. For example, 4 squared is equal to 4 times 4, which is equal to 16. Next, let's move on to square roots. Let's say n squared, which is n multiplied by n, is equal to m. Then n is the square root of m, as the square root of m is the number which, when multiplied by itself, results in m. We denote the square root of m using a square root symbol, as shown. For example, the square root of 36 equals 6. This is because 6 times 6 is equal to 36. Importantly, as we will learn in future lessons, the square root of a positive number actually has two answers, one positive and one negative. So the square root of 36 is 6, but also minus 6. This is because 6 times 6 equals 36, but so does minus 6 times minus 6. As two negative numbers multiplied together equal a positive number. Next, it's important to understand the relationship between squares and square roots. Squaring and taking the square root are inverse operations. This means that they undo each other. If you square a number and then take the square root, you get the original number back, and vice versa. For example, the square root of 4 squared is equal to the square root of 16, which is 4. Similarly, if you start with a square root and then square it, you get back to the original number that you started with. For example, the square root of 9 squared is 9. Now let's move on to cube roots. When we raise a number to the power of 3, we are cubing that number. In mathematical terms, if n is a number, then n cubed represents the number n multiplied by itself twice. For example, 2 cubed is 8. 3 cubed is 27, and 4 cubed is 64. The cube root of a number is the inverse operation of cubing. To find the cube root, we ask ourselves, what number, when multiplied by itself twice, gives us this number? So looking at our examples, the cube root of 27 is 3. This is because 3 times 3 times 3 is equal to 27. Likewise, the cube root of 8 is 2. This is because 2 multiplied by 2 multiplied by 2 is equal to 8. Let's work through an example. Suppose you are given the volume of a cube and need to find the length of one of its sides. If the volume of the cube is 64 cubic units, we can determine the side length by finding the cube root of 64. So to find the cube root of 64, we need to ask, what number multiplied by itself twice gives us 64? Pause the video to see if you can work this out. The cube root of 64 is 4, so the side length of the cube is 4 units. This is because 4 times 4 times 4 is equal to 64. Understanding and practicing these concepts will help you to tackle more complex problems with confidence. In today's lesson, we explored the concepts of square and cube roots, which are essential components of the number system. We began by defining a square number and introducing the idea of square roots. We also discussed how this is the inverse operation to squaring a number. We then did the same for cube numbers and cube roots. Understanding square and cube roots equips us with powerful tools for tackling more complex problems, including those involving three-dimensional spaces and volumes in disciplines like physics and engineering. Watch the rest of the GCSE Maths course at Sophos Education.